In an interlocking assembly, parts can be assembled step by step. Once assembled, there is only one movable part called the key, while all other parts, as well as any subset of parts, are immobilized. Here is an example of a non-interlocking assembly, which have multiple movable parts and movable part groups. Here is an example of a deadlocking assembly, which does not have any movable part or part group. Thus, it cannot be physically assembled. We present a new method to efficiently create interlocking assemblies. The following interlocking assemblies are created with our approach. Given an input model, we use a recursive tree traversal with backtracking to iteratively generate interlocking parts. First, we generate a set of candidates A1 by choosing different key parts. Next, we enumerate all possible A1 and rank them according to the compactness of R1. Similarly, we generate the set of candidates of A2 from the top ranked A1, the set of A3 from the top ranked A2, and the set of A4 from the top ranked A3. However, we cannot find any A5 from the top ranked A4. Hence, we backtrack to the second ranked A4 yet still fail. Backtrack to the third ranked A4. Parent of A4. The sibling of the parent. And another sibling. Until we can generate the set of A4 from the new A3. Finally, we generate the set of A5 from the A4, resulting a 6-part interlocking cube. Please refer to the paper for more details.